Okay, so how many of you actually did the calculation of showing that the tidal force or the residual force is actually proportional to 1 over r cubed? I bet nobody did. But anyway, you can use Google to do that. So let's simplify this figure and show it this way, where we have removed the centripetal force and the gravitational force, and we are only showing the residual force, which corresponds to the net tidal force, tide generating force, right? So here it is, tide generating force is proportional to 1 over r cubed. Looks just like a gravitational force, but it's 1 over r cubed. Here you can imagine that m1 is, let's say, the mass of the moon or the sun. M2 is the mass of the air parcel or the water parcel that is experiencing this net tide generating residual force. Okay, so what does it do? We said on these points connecting the pole to pole, the circle that's connecting the pole to pole is got a residual force that's pointing towards Earth's gravity, so it's not doing any tidal generation. And the zenith, which is pointing to the moon, also has a force that's vertical, so in the direction of gravity, no residual horizontal or tidal force, the same at the nadir. So you have these three being shown here, where the tide generating forces are 0. So as you go along the Earth, you can imagine the entire planet is now covered with water, the aqua planet, because we're going to do the idealized tides, which are not feeling any bottom friction or so, and the entire planet is covered with water, the aqua planet. And the tidal force is 0 here, increases, reaches its maximum here at the blue arrow, decreases to 0, the same thing here, increases maximum to 0, increases maximum to 0, and so on. So imagine water parcels or the ocean all over the Earth being pushed. Maximum push here continues to be pushed towards the equator, push towards the equator, push towards the equator, and push towards the equator. So you're going to end up with maximum bulges on this side and this side, because these forces are pushing the water. Remember, the whole system is rotating. It's like putting a spoon in the teacup and rotating the tea and creating a trough, not a bulge, right? So this is a rotating system still. Okay, that's how we are getting the centripetal force in terms of the rotation because of the barycenter, right? So this is how the tidal bulges look in the idealized situation, where all the Earth is completely covered with water, aqua planet. Okay, idealized tidal bulges, which are called equilibrium tides, as we will see later on. Okay, so this is the ocean should look like this, the dotted line where it has a certain depth. We have covered the entire planet with this ocean. As soon as we turn on the wobbling of the Earth-Moon system and the barycenter around the sun, we are going to have residual tidal forces, which are very small, but they can push the water and produce this bulge. So you have one bulge pointing towards the moon and one bulge pointing away from the moon. Okay, so just stare at this figure and make sure you understand. Okay, no complication, just 1 plus 1 plus 1 again. Very simple concepts we have added here, and we have produced these two bulges on either side of the Earth. What are we going to do? We are going to start adding complications where the moon is not anymore in reality, it's not on the equatorial plane of the Earth, right? It's tilted to the equatorial plane, just like the Earth is tilted to the plane of the ecliptic around the sun. So the moon has a declination with respect to the Earth's equator, and the whole system has a declination with respect to the plane of the ecliptic. So where the bulges are is going to depend on where the moon is then, right? So we're just going to move the bulges because of the declination of the moon. So we'll see that in the next podcast, but make sure you understood these very simple concepts: barycenter, centripetal force because of the wobble, and gravitational pull by the moon. The net gravitational pull is 1 over r cubed because of this difference from the center of the Earth to the surface, and the residual force and thus ends up being proportional to 1 over r cubed, maximum at 45 degrees to the equatorial plane in an idealized situation, and the bulges facing the moon and away from the moon. Very simple concepts. 1 plus 1.